didn't see you there. It's just about to get started with our pre-algebra lesson. Today we're doing a mixed review. Which method should you use? Print out the PowerPoint, work the problems with me. Now let's get started.
It's Virtual Math with Mr. Ferrara. Hey, what's up everybody? Today we're going to be doing a mixed review. Which method should you be using for systems of equations? We're just going to look at a bunch of problems and decide which method is best suited for those problems. Now, just a reminder, there are 3 ways to solve systems of equations. I don't think any of you are going to be picking up graph paper to use, so really there's only 2 methods that we're going to look at. The first one was substitution. That's ideally when you have one variable by itself and you're able to substitute one equation into another. When one equation can be substituted into another, you're replacing one variable with the other. Then you're able to solve the equation for that variable. Mystery word number 1 is summer. I can't wait for the summer. A reminder about elimination. Elimination is primarily used when you have x and y on the same side of the equal sign. Once you have the variables on the same side, you're looking to eliminate one variable by getting the positive and the negative version of that variable. Then you would add and solve for the variable that you have left. If while doing this method, one variable does not cancel, you should restart because you're doing the problem incorrectly.
All right, so we're going to jump right into some examples. Now the goal is to be able to decide which method each problem is better suited for. Looking at example 1, I see negative 3x plus y equals 7 and 4x minus 2y equals negative 12. Now honestly, this is set up for either method. I could move this negative 3x to the other side and get y equals something, or I could do elimination since y is by itself. I think I'm going to stick with elimination because for me, that's the easiest one to work with. I see a 1 in front of this y. That 1 needs to turn into the opposite of a negative 2. Well, the opposite of a negative 2 is a positive 2. So in order to turn that 1 into a positive 2, I multiply that top equation by 2. 2 times negative 3x is negative 6x. 2 times 1y is 2y. And 2 times 7 is 14. I didn't do anything to the bottom equation, so I'm going to leave it alone. 4x minus 2y equals negative 12. When we do elimination, we multiply, then add our 2 equations together. Hopefully one variable will cancel, and I notice that I have a positive 2y and a negative 2y, so those are going to cancel. Negative 6x plus 4x is negative 2x, and 14 plus negative 12 is a positive 2. I'm going to divide both sides by this negative 2, and I find out that x equals negative 1. When I find x to be negative 1, I need to solve for y. If you get your x, you need to solve for y. Now when you do the elimination method, you can pick whichever equation you want to work with. So I'm going to go with the top one, negative 3x plus 1y equals 7. I'm going to plug in this negative 1 in for x. So it's negative 3 times negative 1 plus y equals 7. Negative 3 times negative 1 is positive 3 plus y equals 7. We're at a one-step equation. We just need to subtract 3 from both sides. And I find out that y equals 7 minus 3, which is 4. So the coordinate where those 2 points will cross is negative 1, comma 4. Negative 1, comma 4. That's the solution to example number 1. Now again, you could have done that with either elimination like I did, or you could have used substitution. Either way, you would have gotten negative 1, 4 as an answer. Now, example 2 is a little bit more clear on what method we should be using. X equals negative 3y plus 5, and 4x minus y equals negative 6. I notice that x is completely on a side by itself. That hints towards substitution. I see that x is the same as negative 3y minus 5, plus 5. X is the same as negative 3y plus 5. So I'm going to replace this x with negative 3y plus 5. So 4x gets replaced, substitution, with negative 3y plus 5. Then I bring down the rest of this. Minus y equals negative 6. I now need to distribute and solve. 4 times negative 3y is negative 12y. 4 times 5 is 20. This negative y is not attached to the distributive property. And I rewrite the rest. I'm going to put a 1 in front of my negative y, just to remind myself that's a negative 1. I now need to combine like terms. Negative 12y combined with a negative 1y is a negative 13y. Bring down my positive 20, bring down by negative 6. I'm now at a two-step equation. Subtract 20 from both sides. Negative 13y equals negative 6 combined with a negative 20 is a negative 26. Divide both sides by negative 13. And I know that negative 13 into negative 26 goes a positive 2 times. Well, if I solve for my y, I need to solve for my x. I pick the equation I want, and I'm going to go with the first one. Again, that's the easiest one. X equals something. So I know that x equals negative 3y plus 5. Well, I'm going to plug this 2 in for y. X equals negative 3 times 2 plus 5. Negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 1. So I got my x, I got my y. So my coordinate is negative 1, comma 2. Again, this problem was set up very clearly for substitution because x was by itself. If you wanted to do elimination, you would have needed to move this negative 3y to the other side. In order to do that, you would have had to add 3y to the other side. Then you could have set up this problem for elimination. Problem 3, I'll let you decide. Is this set up for substitution or elimination? Hopefully you said substitution because 2y is by itself. I need to do one little fix to this problem. I need to divide everything by 2. Now, could you have done this problem with elimination? Yes, you would have needed to move the 4x to the other side. Then it would have been a setup for elimination. I'm going to stick with substitution. I divide everything by 2, so I get y equals 4 divided by 2 is 2x. 4 divided by 2 is 2. So this equation turns into y equals 2x plus 2. I know that all y's can be replaced with 2x plus 2's. This y is going to be replaced with 2x plus 2. So the 2x, nothing happened to it. Plus 5 stays 5, but I'm going to replace y with 2x plus 2. And that equals negative 26. I now need to distribute. 2x plus stays. 5 times 2x is 10x. And 5 times 2 is 10. And that equals negative 26. I now need to combine my like terms. 10x and 2x are alike, so I get 12x. Bring down the rest. I'm now at a two-step equation, which I need to solve. Subtract 10. Subtract 10. Bring down my 12x. And negative 26 combined with a negative 10. Negative 26 and another negative 10 is negative 36. Now to one-step equation. Divide both sides by 12, and I'm left with x equals negative 3. If I find my x, I need to solve my y. I always go back to the originals. I'm not going to use this new equation over here. I'm going to go back to the original one. Okay, and the original equation was 2y equals 4x plus 4. X equals negative 3 gets plugged in, so it's 2y equals 4. X gets plugged in for negative 3 plus 4. This whole right side can be calculated. 4 times negative 3 is negative 12. Negative 12 plus 4, negative 12 plus 4 is negative 8. Bring down my 2y. I'm at a one-step equation, so I'm going to divide by 2, and y equals negative 8 divided by 2 is negative 4. So my x comma y is negative 3, negative 4. There's the solution to example 3. Mystery word number 2 is subtract. One more example to work on. Again, I'm going to ask you before we get started, negative 3x plus 4y equals negative 22 and 2x minus 3y equals 16. Which method is this problem more adequately suited for, substitution or elimination? Hopefully you said elimination. X and y are on the same side. I don't want to do any moving around if I don't have to, so substitution is not going to be the best choice. Elimination is a little bit better for this problem. Now, there's no clear variable that we can work with, so I'm going to stick with x's. Whenever I don't have a clear variable to work with, I stick with x's. I have a negative 3x and a positive 2x. What is the least common multiple of 3 and 2? Hopefully you said that's 6. I could turn a negative 3 into a 6, and I could turn a 2 into a 6, so that's our best choice. Now, one of them wants to be a negative 6, so I'm going to stick with the negative, and I'm going to keep that to be a negative 6. I need to distribute to all three terms. Negative 6x, 2 times 4 is 8y, and 2 times negative 22 is negative 44. I didn't do anything to this bottom equation yet, so I need to multiply this one as well because this is not a positive 6. I need to make it into a positive 6 by multiplying it by 3. 3 times 2x, 6x. 3 times negative 3, negative 9y. 3 times 16, positive 48. I now add my equations together. Once you multiply, you add. If one variable doesn't cancel, we need to rethink our strategy. Negative 6 and a positive 6 do cancel. 8 plus negative 9 is negative 1y. Negative 44 plus 48 is a positive 4. I'm now at a one-step equation. I need to divide by negative 1. And I get y equals negative 4. Once I got my y, I need to solve for my x. Now I need to pick which equation I want to use. It really doesn't matter which one you choose, so I'm going to pick the bottom one. 2x minus 3y equals 16. Y is negative 4. So I will replace my y with negative 4. I need to multiply these out. Negative 3 times 4 gives me a positive 12. That equals 16. I'm at a two-step equation. Subtract 12 from both sides. We get 2x equals 16 minus 12 is 4. Divide both sides by 2. We get x equal to be 2. X comma y, 2 comma negative 4 would be my final answer for this problem. So again, you can do any of these problems with either method, but problems are better suited for one method or another depending on how they're set up. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.